So experimentally it was found that when we were saying, like in the last class I have said you that for the current to be flowing, what we need?
Like a full closed circuit.
No, closed circuit as well. Okay, and what
So you
about
need a
what else?
battery,
Yes, battery.
like a
There
source of the current.
there has to be potential difference. That is the main thing for the current flow. Okay, what
Yeah,
should be there? Potential difference.
battery.
Okay, so for the
Yeah.
potential difference we add battery. Okay, and that this is the
Okay.
sign of a battery. Okay, if the circuit
Okay.
is completed, then the current flows in the circuit. Okay, so
Okay.
experimentally it was found out that the current was flowing in the wire. Okay, the current which was flowing in the wire, it is proportional to what? Voltage. Okay, it was
Okay.
found out that it is proportional to the voltage. Okay, so
Okay.
now we know that it is what? It is a proportional. Okay, but what will be the
Yeah.
constant if we just write, okay, something is
Mm.
proportional, if something is proportional to b, and if you're writing the formula, there has to be some constant that is multiplied, gets multiplied, and then you get the formula, right? That is
Then that's the
that's
R value,
exactly.
resistance.
So but it is, if it is r, how will you find out? Okay, then there was a one more scientist. This was found out by another scientist. Okay, and this was this was found by Ohm. Okay, there was a scientist Ohm. It was found out that when you remove the proportionality and you find the constant, so this is what? This is IR. Okay, or we can write it V is equal to IR. Okay, so what was the
Okay.
constant? Constant was R, that is resistance, and it was found by Ohm. Okay, there was a scientist
Okay.
George Simon Ohm. Okay, so he found out that this is a constant that is coming. Okay, what you do, you find some voltage value and you find some current value, and then you divide them. Then what it will give you the value? It will give you the value, resistance of the wire. Okay,
Okay.
so where V is voltage that you have applied, voltage applied, I, current flowing, okay, into the wire, into the wire.
Wait, it's delta V equal to R, right?
No, no, it's
Or
just V, not delta V. And this
okay.
is, what R is constant. Why there will be delta V? Because you have just battery, so battery has one voltage only, right?
Yes.
Okay, so R will be the resistance of the wire, resistance of the wire. Okay, so then this relationship V is equal to IR, it is said to be what? Ohm's law. Okay, this is said to be Ohm's law. Okay, using this formula you can write, you can find the current as well. I will be equal to the, if the voltage, if the any two things are known, you can calculate the what? You can calculate the other quantity. Okay, the third one, I is equal to V by R, or R is equal to V by I. Okay, so you could do that.
Okay.
If two quantities are known, then the third could be calculated. Okay, that is Ohm's law. Okay, now one more thing. In the Ohm's law, when we have made the diagram, suppose I is what? I is V by R, right?
Yeah.
Okay, so what is R is constant, right?
Yeah.
It's not a variable quantity. It has to be, like, if you have a wire. Okay, if suppose you have a wire using in the circuit, if you are using this wire is in circuit, suppose it's a copper wire. So whatever the resistance it will be having, that will be constant, right?
Yeah, it'll be constant.
Okay, so the resistance will be constant. Okay, that's not going to change. So if it's not going to change, so it will be constant. So can we write I? I is proportional to V, right?
Yeah.
Okay, I is proportional to V, and R, 1 by R, 1 by R is constant. Okay, we cannot make the diagram of V proportional to I because it is not found so. Okay, what is found so? It is important in Ohm's law that the current found into the wire, that is proportional to the voltage, not the other way around. Okay, so you just remember that.
Okay.
Okay, current flowing into the wire is proportional to the voltage applied. Okay, that it is the line. Okay, so that is why we make the diagram of I proportional V. Okay, so if we make the diagram of I proportional V, since they are proportional, okay, directly proportional, so it will be I, it will be V, and we'll get the straight line, right? Okay,
Okay.
we'll get the straight line. And what I over V is, if we write delta I, because we are taking so many values here, so delta I over delta V is equal to what? 1 by R. So which is what? Which is a constant quantity, right?
Yeah.
Okay, so
Then that means it'll be
that's
linear.
why we see a slope constant, okay, into this. But this Ohm's law, there is some significance. Okay, it's not just like you cannot use it for every kind of material. Okay, Ohm's law, so there are some conditions. Ohm's law is valid only for metals. Okay, so in the case of metals you will get this curve. Okay, so if someone is asking you that suppose the resistance is given, then current is given, and found the voltage value, or voltage and current is given, found the resistance value, you could do this only in case of metals. Okay, you cannot use this formula for in any other case. You can use this formula specifically only for the conductors which are metals. Okay, suppose if you have if you have if you have any other metal. Okay, if I'm suppose I'm using any semiconductor, okay, which is which is insulator and the conductor both, okay, at some particular amount of the temperature. Okay, so if I'm using semiconductor, that is another material, another type of material that is not fully conductor. Okay, so if I'm using a semiconductor, what happens in that case? If I make the diagram of I is proportional to V, so we don't get the straight line, we get this kind of curve. Okay, it is happening because the Ohm's law is valid only for metals or conductors. Okay, so this is for semiconductor. Okay, so Ohm's law is not valid, so you
Okay.
cannot apply V is equal to IR. Okay, it's not valid. You can write metals or conductors. Got it?